And good morning, everybody. Welcome to week 3 of the third quarter, week 3 of the second semester. You guys are becoming experts at this. You know what to do, right? You know what it's worth, too, right? How many points do you get for this? Well, none directly, but indirectly, you'll end up with all sorts of points by doing these warm-ups. Why? What does that mean? Well, if you do the warm-up, then the homework's easy. You're more likely to get the homework done. And if you do the warm-up and the homework, then the tests are easy. You're more likely to score higher points. So the idea of doing the warm-up, it shows a little integrity, right? If you do it, definitely pat yourself on the back because you're doing it even though in some ways no one's looking, right? We'll see the indirect effects with a higher test score, more homework done. But you won't see the direct effects of like points, right? Unless I make it into a ed puzzle or something. So you do this, you feel good because you have some integrity, but you get rewarded by going to the homework and having an easier time and feeling better about the homework and then going to the test and having an easier time. So you know the drill, all right? Go copy this down, press pause, go try everything, come back, see how you did, or see some hints. Before you go, let me show you a couple hints on how to do some things. Remember, first off, these line segments, your math teachers have been lying to you since kindergarten. Technically, every line has no end on both ends, right? It goes forever in both directions. Okay, that's what a line is. It goes forever in both directions. To make things easier, we called line segments, which is pieces of lines. It has an endpoint on both ends. Lines, for most of math up until now, we'll be more specific most of the time and call that a line segment. So how long is each line segment? You're going to write an expression. Remember an expression? 3 plus 4 is an expression. Right? 42 divided by 7 is an expression, right? And x plus 4 is an algebraic expression. That's kind of what we're going to be doing here. So how long is this line? Well, it's x plus 3 plus x plus 3. How hard was that? Well, you don't want to end there. You want to make it as simple as possible. And I could put the two 3's together. 3 and 3 make 6. And the two x's together. X plus x is the same as 2 times x. And how will you write 2 times x plus 6 when you're in 8th grade? Well, you're going to drop the times sign and just write 2x plus 6 because the times is implied, right? That means 2 times x, but you don't have to write it, okay? All right? When you get done with these 5 more expressions, evaluate each expression for the value given. Don't freak out by those big words. You just get to play soccer coach and substitute. What does that mean? If x equals 4, then I could put a 4 in for x, right? It's the same thing, right? So I'm going to write not 24, but now it's important that I put that times sign because I have 2 numbers together, and if not, it looks like 24, right? So I have to put that times sign. 2 times 4 plus 6. 2 times 4 is 8. 8 plus 6 is 14. Okay, that's what you're going to do on these. Some of these have A's. A's will be equal to 2.25, 2 and 25 hundredths. Okay, now on these next ones, simplify. This top row is mostly regular fractions where you can simplify it because you can find a number that goes into the top and the bottom. That's the same, a common factor of 10 and 25. What number fits into 10 evenly and fits into 25? Well, that ends in a 0, that ends in a 5. So I know 5 goes into both. How many times does 5 go into 10? Twice. And how many times does 5 go into 25? 5 times. So 10 25ths simplifies to 2/5. Okay? That's how you're doing most of the top row. Okay? And then this bottom row, most of these are improper fractions. You notice the number on the bottom is smaller than the number on the top, right? Which means that all of those are going to be greater than 1. Now, how do you simplify an improper fraction? You divide the bottom into the top. So in this case, 20 thirds, I'm dividing 3 into 20. Why? Because every group of 3 is equal.
Good day, everyone. And
sorry about that. Every group of 3 is equal to 1 whole. So how many 3s fit into 26? So 20 thirds is more than 6. Okay, then I multiply. Now here's the cool thing. Your remainder is going to come on top, and your divisor, what was on the bottom, will go on the bottom. So 6 2/3 is the same as 20 thirds. Okay? All right, that's how you're going to do all these. Go do it. Come back and let's see how you did. All right, what do we got here? Most famous diamond ever. What 2 numbers have a product of 42 and a sum of 13? 7 and 6. How about a product of 36 and a sum of 13? Now, I'm thinking 6 times 6 is 36, right? But 6 plus 6 is only 12, not 13. I don't know if you ever noticed, whenever you add 2 numbers that are the same, 6 plus 6 or 7 plus 7, 5 plus 5, 11 plus 11, 122 plus 100, you're always going to end up with an even sum for your answer, okay? When you're adding 2 numbers that are the same, unless, you can say, well, what about 6.5 and 6.5? That makes 13. Yeah, 2 whole numbers, right? Whenever you have parts, then you can end up with an odd sum. But if you're doing 2 whole numbers that are the same, your answer will always be even. So 6 and 6 won't work. What will work there? Well, 9 times 4 also equals 36, but now 9 plus 4 equals 13. Okay, how about 24 thousandths and 38 hundredths? That's just going to be 3 tenths, which is 30 hundredths, and 8 hundredths, right? When I add those, remember that your key when you add or subtract or compare decimals is to stack them and line up that decimal. Okay, and then if you're adding, subtracting, and one only comes out to like the tenths, the other comes out to the hundredths, they come out in different place values, fill in zeros afterwards so it's less confusing. Now, when I add or subtract, the decimal's coming straight down, so I get my 38 hundredths when I add. And remember, when you multiply, the key is to pretend there's no decimal and multiply first, right? So 3 times 8 is 24. But in order to pretend that 3 tenths was 3, I had to move the decimal 1 spot to the right. In order to pretend that 8 hundredths was 8, I had to move the decimal 2 spots to the right. That's a total of 3 spots I moved decimals in my problem, so I have to go back 3 spots in my answer. When I go back to this 3rd spot, there's empty space there. I always say, fill in the egg card. Okay? Works. Now, did I stump you on this next one? I probably did. You're not used to these yet. It is 3 times 2 1/2, right? 3 2s is 6, 3 halves is 1 1/2, 6 1 1/2 is 7 1/2. Or I go 2 1/2, 2 1/2 is 5, and 5 2 1/2 is 7 1/2. When I add 3 plus 2 1/2, that's 3 0 halves, right? So 0 halves and 1/2 is 1/2, and 3 2 is 5. Okay? All right, we already did this one. Let's go to the next one. X plus X plus X. Is there an easier way to write that? Yeah, 3 times X. Or 3x. Put the x's together here. I have 2 times x, 1 1/2 and 1 1/4. Those are different denominators, right? 2 1/4. Okay, but I'm lucky here because I know I have to get the same denominator, but 2 fits into 4. So I'm going to say fourths on these. I don't have to change that 1/4. It's 1/4. I just have to change 1/2 to 2/4. And 2/4 and 1/4 is 3/4. 1 and 2. So 2x plus 3 3/4 on this one. My answer. X plus X plus X is 3x, 3 times x, plus 1 1/10. Now, I don't know if you notice, I put the x's first. For some reason, that's what they want. In algebra, they'll want the x's before the numbers. And if you have x's and y's and b's and stuff, whichever one has the highest exponential power. So like x cubed would be before x squares, and that'd be before x's, and then you go to the numbers. Okay, that's just the way they do it. It equals the same thing. That's just the way they do it, though. Okay, so I have 3 of these a's and 1 x. I'm going to go ahead and put the a's first. 3 times a plus x. Okay, and then x plus a. No more X's, no more A's, so they're by themselves. And then 1.25 and 1 3/4, I need to either change this to decimals or this to fraction. Either way, a lot of you are starting to recognize 0.25 is 1/4. A lot of you are starting to recognize 3/4 is 0.75. If you didn't, remember the rule. You want to find out what a fraction is as decimal, divide the bottom into the top. That is a common rule when you're dealing with fractions, right? Changing a fraction to a decimal, but also simplifying an improper fraction, divide the bottom into the top. Okay, so 4 won't fit into 3. Of course it won't. It's not improper. So the reason I was doing this anyway is to get decimal. Add a decimal. 3.0 is the same as 3, but now I can go 4 into 30 and say that's 7 times. When I get a remainder, go ahead and add another 0. And 4 goes into 20. So I got 0.75. So now when I go to add these, I have 1.25 and 1.75. And those are what's called compatible numbers. Why? Because they fit together to make a nice round number. So that's 3.00. I'm just going to call it 3. I don't need a decimal if I don't have to have it, right? Equals the same thing. Now, second step, go back and evaluate. What do we do here? Substitute. You play soccer coach. I already put the 4 in for the X on that first problem. I got 2 times 4 is 8. 8 plus 6 is 14. Now I'm just saying 3. That's not 34. 3 times 4 is 12. Okay, and I should probably show my work here and put the 3 times 4 up there, right? Probably above this, right? Now, 2x plus 3 3/4, I'm going to say not 24, 2 times 4 plus 3 3/4, which is 8 plus 3 3/4, which is 11 3/4. All right, 3 times x, we already figured out. That's 3 times 4 is 12. 12 plus 1.1. Hopefully when you add that, you don't put it like this, huh? That would be a mistake, and that's a common mistake. So if you start to do that, you're not alone. Remember, though, always remind yourself when I'm adding decimals, I got to line up that decimal. Where's the decimal in the 12? Remember, when you can't see it, it lives on the right side. So if I put the 12 with the decimal there, now I'm probably going to put a 0 here so it looks less confusing. 12 is the same as 12.0, and I get 13.1. Okay? So 13.1 after I substitute a 4 in for x. Here I got a 4 plus 3 times 2.25. Let's go on the back and do this. Remember, when you multiply decimals, you pretend like there's no decimal there. So 1/675, but I moved it over twice to pretend it wasn't there. I got to go back twice in my answer. 6.75 plus 4. And again, hopefully you didn't say 6.75 plus 4, right? Where's the decimal on the 4? Over here. So 6.75 plus 4.00 equals 10.75. Okay? So this one ends up being 10.75. Last one. 4 plus 2.25, right? I substitute a 4 in for the x, a 2 and 25/100 for the a. I'm going to put the 4 and the 3 together first, get 9. Where's the decimal in the 9? It lives on the right. Make sure you stack them and line them up. Fill in zeros if it helps. So this ends up being 11.25. All right, last few. What number goes into 3 and 12? 3. Always see if the smaller number fits in a bigger number. 3 goes into 3 once. It goes into 12 4 times. 3/12 is the same as 1/4. What goes into 35 and 42? Well, if you're getting good at your 7s, you recognize those are multiples of 7. This is 7 times 5, and that's 7 times 6. Okay? Those are both even, so 2 goes into both. 2 goes into 8 4 times. 2 goes into 18 9 times, 4/9. And those both into 0, so I know 10 goes into both. 10 goes into 50 5 times, goes into 70 7 times, 5/7. Okay? Now this, I can find a number that goes into 6 and 15, and it's improper. So I could do the simplifying first and the dividing the bottom into the top, fixing the improper fraction second, or vice versa. Okay, I'm going to do it both ways for you. 6 goes into 15 2 times, because 2 times 6 is 12. Remember, your remainder is going to go on top, and what was on the bottom goes on the bottom. Now, 3/6 simplifies to 1/2, right? So that's 2 1/2. Now, if I simplified first and said 3 goes into 15 5 times, it goes into 6 2 times, I would have 5 over 2, and I divide the 2 into the 5. Now, that goes 2 times, because 2 times 2 is 4. My remainder goes on top, divisor on the bottom. 2 1/2, 2 1/2, same answer. Okay? All right, same thing here. You can simplify first. I'm going to go ahead and do that and say 2 goes into the top and bottom. It goes into 30, 15. How did I do that fast? 2 goes into a number. You just cut it in half. That's how many times. So half of 30 is 15. 2 times 15 is 30. Okay? 4 goes into 15. How many times? Not quite 4 times. 3 times, right? What's my remainder? It's going to go on top. What was on the bottom goes on the bottom. 3 3/4. Okay, now what goes into, I know 5 goes into it because one's in a 5, one ends in a 0, but I like money, man. These are quarters, right? 4 quarters is $1. 3 quarters is 75 cents. That's the same as 4 over 3. Divide the bottom into the top. That goes 1 time. And my remainder goes on top. Divisor on the bottom. 1 1/3. Okay. Now, 10, I'm going to leave that. I know I can simplify it, but 10 is such an easy number to divide. So I'm going to say 10 goes into 96 9 times. My remainder is going to go on top, 6 tenths. Now I'll simplify 6 tenths because 2 goes into 6 3 times and a 10 5 times. All right. All done with your first warm-up of the week, and this will benefit you greatly. Tomorrow we're going to do this. You're going to have to simplify 10 25ths, 3 12ths, 35. Well, these numbers look familiar, don't they? Yeah, all the way to 96 tenths, right? Look at that. Half your work's done if you did the warm-up. Shh. Don't tell anybody without integrity. You get the reward. We'll tell them later after they do all the work. All right. Have a good one, everybody.